Welcome to another episode of Complete Developer Podcast, the podcast by coders for coders about all aspects of creating your best life as a developer.
I'm Will, the accomplished developer, author, and software architect.
And I'm Beej, the journeyman developer sharing my journey in development.
Complete Developer Podcast is supported by listeners like you. We are now on Patreon at www.patreon.com/Complete Developer Podcast.
Integration points in complex systems have a tendency to surprise you, usually in an unpleasant fashion. I would think that there wouldn't be very many pleasant surprises when it comes to those.
Well, when you find one that actually worked and you didn't know it was there, that's about as far as that goes. Yeah.
While it takes a while to discover the underlying anti-patterns that caused the system to have problems, there are certain smells you can look for that indicate common sources of issues. In this episode, we'll discuss integration smells that will help you find a lot of integration problems before they become an issue. While not at all comprehensive, these are things that you see over and over again in a lot of different environments. But before we get started, Will, what's been causing integration problems for you?
Well, I'm actually trying to get integrated on a new team. So today was the first day at the new gig.
Nice.
And the stack is completely different.
Mm-hmm.
Like I'll be doing React, TypeScript, Node, Postgres versus, .NET, Angular, SQL.
Mm-hmm.
So that's a pretty big jump. But I think it'll be okay because it seems like it's a pretty good group. So
that's cool.
Yeah, we'll see. I'm just trying to get through all of the onboarding tasks so that I can code.
Nice.
That's where I want to be.
Yeah,
because
I get that.
I've been getting progressively more stir crazy, and I think you can tell that from my Hangouts messages.
Yep. And I totally get it because we're about to go to production, so there's not a lot of coding left. We're doing like some, last minute cleanup and stuff like that, and trying to wait it out so that we hit it. We're doing some server updates, and so we're trying to time it right and get enough work to keep going for a team, for the whole team. So a lot of my job as the lead is finding work for people and not actually getting to code myself. So I feel you, man.
Yeah. So that's what I've been doing. How about you?
Well, other than trying to find work for my team, I got a new piece of art. Well, I haven't actually received it yet. I just bought it yesterday. But super excited. It's an original from my favorite artist. She's the one who designed the tattoo that I have on my arm. She gave that to me for my birthday. She and her husband are good friends of mine. But she posted about selling some originals, and one of them happened to be one of my favorites of hers that I told her, hey, when you sell this original, I want it. And so I saw that post, immediately texted her, and Venmo'd her the money right after that. So I have a new piece of art coming up. And if you guys are interested, once it comes in, I will definitely be posting it. It'll come in before this episode airs. So I'll definitely be posting it on our social media with a link to her stuff if you like the style.
Saving money is hard, especially when you actually have a favorite artist.
True that, man.
Because I'm I can't think of one.
Yeah,
for me. Yeah.
Lucas Casadas is a fee-only certified financial planner. He owns and runs Level Up Financial Planning virtually out of Fort Collins, Colorado.
And just like us at Complete Developer Podcast, he focuses on helping you to not only establish a real plan for your finances, but to also take action on that plan so that you can use those finances to create your best life.
Guys, investing in financial planning services really comes down to whether or not you can improve your finances. And the great thing is, with the help of Level Up, the compounding impact of making those better financial decisions is easily going to pay for itself.
And speaking of paying for it, Level Up also has a unique pricing model that will help you no matter where you are in your financial journey. So it's not too early to start right now.
Yeah. And to top it all off, Lucas is a fiduciary for his clients. What that means is he's not here to sell you anything, but instead to help guide you to a better financial situation.
And from the guidance perspective, You should check out his podcast, Techie Personal Finance Bootcamp, where he covers financial topics that you probably face and interviews other IT professionals who share how they navigated their own careers. And you can learn even more at levelupfinancialplanning.com.
If you're working with integrations in a large software program, project, whatever, I can't read, you are probably aware that the complexity of these programs, projects, okay, I threw that in there myself, often lead to additional errors that are harder to predict and troubleshoot. It's very similar to the situation a lot of people encounter when dealing with complex object models. Oh, yeah. It takes sort of forever, really forever, seems like, to dig through the mess to actually find the problem. As a result, object-oriented developers have a set of heuristics for finding areas that are potentially problematic. And these are typically referred to as code smells. I really love the word heuristics, man. I'm glad you threw that in here.
Yeah, I thought I was going to really get... I really thought you were going to rake me over the coals over the $3 words that were in that one, but...
Oh, no. You know I love them.
Yeah, that's why I figured you would. Now, in a larger, more complex scenario with multiple interacting services, there is also the concept of a smell. While there's a huge list of them, and you could just find them online, honestly, we really can't cover all of them here. But there are certain ones of them that are really easy to spot, even if you're not overly experienced with the particular code base that you're looking at. Now, these smells by themselves are not necessarily a proof that something is actually a problem. They're just like other code smells, right? The code can still work and do just fine. It's just, hey, this is an area I need to look at because there might be something here. And that's what it does. It points you to a problem location that might exist. It's probably the best way to look at it. And like most heuristics, when you make a decision based on it, that decision needs to be backed up with data, which is a lot easier to get from a few suspect locations as opposed to a broad system, especially, again, if you're not used to that particular system.
So in this episode, we're going to discuss some very common smells that occur in larger development projects with multiple services. In particular, we're going to discuss some smells around integration points that can give you a clue where the system might have a problem. They should not be used as a replacement for careful measurement and diagnostics, but rather an opportunity to sort of dig deeper to help find the real problem.
Yeah, I wanted to emphasize that because I don't want somebody going, well, Will said, it's like, look, I didn't say that this is a problem.
Oh my goodness.
Don't
if
put that one on me.
Well, Will said you need to run and hide.
Yeah.
For real, y'all. Yeah. You don't want to be doing that. Trust me, I've known him long enough to know that.
Yeah. There's I give my advice, but yeah, you're supposed to see where it goes, not go where it goes first. So speaking of where things go, the first one on my list, and this is kind of my personal list of stuff that I look for in a big system to go, okay, where are the problem spots? When the deployment order of services matters, I look at that and go, okay, there's probably something here. There's a fair chance. Now, a service may get deployed and have degraded functionality if it's dependent on another service that isn't present yet or that isn't at the current version. But it shouldn't just fall over and die. And when this happens, it implies that the service in question is overly coupled to its dependencies.
Yeah, I follow that. Man, that makes a lot of sense.
Because like if something's not there and you die from it not being there, you are definitely dependent on it.
Yeah. I guess it sort of depends on the service and stuff and how centralized you make your services.
Yeah, and that's also part of it too, right? So like if it is a login service, well, okay, the website's not going to work until that thing works, but the website shouldn't just fall over and die during spin up either.
That's true.
It should handle it gracefully. Now, there are some things in some enterprise systems. There may be like a service locator service, because like we've got to do Java type things in the cloud enterprise. And, so there are cases where stuff can fall over, but you should look for those.
Yeah.
At the very least, go, hey, where can I poke this? Where can I change this where this does not explode? Another great example is, Well, actually, let's talk a little bit more before we get into the next one.
Oh yeah, I was just gonna let you go, man, because you were into it. But yeah, now I will say an interesting subset of this problem happens when a service requests and caches data from other services during that spin up. Such a decision may have been made for performance reasons. I mean, that's why I would do it if I were going to do that. However, you'll often find that performance and abstraction orthogonal concepts. Man, you are really throwing out those big words, dude. I love it. This is great.
Well, yeah. So like it may be spinning up and it needs that piece of data. Well, does it actually need it during spin up? And I know you go, oh, well, if users are going to use it, this data has to be there. And it's like, that's great, but that's not necessarily a spin up responsibility. That should be a background thread potentially that says, hey, do I have the ability to get this data and have retry logic and those kind of things in the mix beforehand? That may be a better way to do that versus just like the raw, actual startup of the app.
I mean, there are certain things that I'm sure that are necessary for
the
startup of the app, like your CSS. I'm kidding. I'm being sarcastic.
Actually, the way I've written some programs, that may be entirely the case. No, but I mean, there are cases, right? Like you're gonna have some stuff that you definitely want to have in the app before users hit it. But that's a different consideration than during spin up, right? You could just go, hey, if this isn't here, this page doesn't load, or it says, hey, there's something wrong. You can't log in right now, because I mean, there are certain queries that you want cached. Just so you don't beat the daylights out of your server. And they typically do a lot of those interactions during spin up to avoid that, so that you don't have like a cascading failure as stuff comes online, after a failure and after cache invalidation. But be really careful with those. Another interesting place is when you have version dependent changes in play, because you may go, well, I've updated, the dependency is being updated to version 1.1, and the thing that's dependent on it is updated to handle 1.1.
Yeah.
Well, you may want to actually have the code side by side and have a feature flag, because if the thing that is dependent on the other thing is looking for version 1.1 and version 1.1 isn't out there, that's a pretty broad surface area of errors to be thinking about. It may be better to switch that config after it goes live, if you can. Now, obviously, there are going to be cases where you cannot. A great example of that I can think of is when we updated TLS.
Oh, yeah, I remember doing that.
That was
not fun.
Yeah. Well, especially when it's deployed software to client site and dozens of client sites.
Yeah.
Some of them don't update their servers till the last responsible minute. And it's like, hey, you're going to have a problem. So yeah, that's something I would be really careful about. The other thing with the whole cattle not pets thing with services, this is a great use case for that, to be able to say, okay, I'm going to spin up, version 1.1 of this thing, and it's going to be ready to go, but 1.0 is still out there until we're sure that 1.1 works, and then we flip it over.
Yeah, I follow what you're saying there,
because you get the users out of the mix. That's a lot of surface area for damage that goes away.
Yep. So the next code smell that we have here is,
and that I do frequently,
integration through data storage. Yeah, I can believe you do this frequently. If multiple applications use the same data, it can be tempting to simply have them all use the same database. While this can work for a while, especially if you're in the 90s or early 2000s, it does introduce quite a few significant implicit couplings between the applications, and the coupling is not really explicit. Okay, that's weirdly worded, but I kind of follow it.
Hence calling it implicit.
Yeah.
Like, let's say that I have an app and it's writing to a particular table.
Yeah.
Okay, I may have another app that's reading and writing from that table. Well, if I change one and it writes some data in there and the other one picks that data up, right, that's now a communication channel between those two apps. And if both sides are not spun up to the same version at the same time, when that happens, one of them is probably going to puke.
Yeah. I mean, this is just more evidence for good CQRS and message queuing. But yeah.
But it gets better. Because when I put a record in a table, or I update, or I select even, in most database engines, you can do a trigger. right? And that trigger can fire off other stuff, put things in other tables. There can also be background processes that pick things up that are actually just running in the database and doing stuff. And changes can propagate a lot further than you think when you do that. So you like people go, oh, if you have a microservice, it should have its own database. This is why, is because it effectively becomes an interface to the service that is probably not handled very well. And a lot of companies honestly don't do a very good job of handling their database scripts in source control, for instance. And that is another area where you will get bitten because people they don't know how to look for that stuff. If that makes sense. So it is really, it's very important to be very, very careful if you have to do this. There are a lot of use cases where you do have to do this, right? It's, they may not have the ability to spin out another microservice. There may be one dev that's working on these 4 apps and they communicate through the database, because it's a Conway's Law thing. So just, be aware of that. Bear in mind too, that like a lot of people, besides the implicit coupling thing, if one service comes under a significant load and hits the database, it can damage the other services that need to read from that database. And, this is particularly important in an enterprise scenario because a lot of times you have an app that writes to the database and a bunch of stuff that reads from the database. So you can end up in a situation where there are, locks, deadlocks, where there's just slow performance. There's a lot of memory usage. There's some other stuff going on. There's inconsistent results coming back. They can get you, is the best way to put it.
I follow. This gets even more fun if there's a significant amount of business logic that's actually in the database, implemented through triggers, scheduled jobs, and stuff like that. You may find that a change to a piece of data propagates a lot further than you really thought, especially over longer periods of time as more of that business logic is applied to it.
Yeah. So you may have data in there from 3 years ago and something hits it today. Mm-hmm. And it may be a script running in the database. And people go, oh, you should never put any business logic in the database. Like, look, dude, your foreign keys are business logic to some degree. Right? Yeah. They're a way of enforcing that business logic. I don't love putting business logic in the database because I don't think the engine is typically the best for that.
Right.
I don't get the flow control. I don't get the reuse. I don't get just a lot of stuff, frankly. Mm-hmm. But sometimes there are performance reasons you have to.
Yeah, I was thinking that. I was like, when I read that, I was like, I'm really opposed to putting any business logic in the database, but there are times where you just have to. There are times that I've had to put triggers in the database and also put stored procs just to get some stuff done that had to be done on the database, and it would have been a pain to try and like write that in the code and have it send it over.
Yeah, pull it across the wire, alter it, and then push it back in.
Yeah.
ORMs are very inefficient at bulk operations typically. And so that's a use case. It also gets kind of weird when you've got multiple apps hitting the same database. This is something else I really didn't think to put in the outline, but one of them needs to add a trigger, right? For whatever reason, it needs to propagate the data somewhere else, but it's not the only one writing to that table. So the other app writes to the table, the trigger fails, the transaction rolls back. Something completely unrelated to anything you're doing just broke your app. It's a definite, if you're going to have a problem, it will be right here. I would almost always say to not ever do this, even though probably 3/4 of the places I've ever worked have done this.
Yeah.
At some level. There are patterns to avoid getting nailed by this one, but you should look and see what you see. The other fun thing is that these things don't happen in real time. So your QAs may not catch it, right? Because it's an app that writes something to a table and the end of year tax processing picks it up from that table once a year.
Mm-hmm.
And you made your change in February.
Yeah.
And that really stinks to be in that situation. And it's even better if there's other processes along the way that change. So you had 2 or 3 of them that contributed to the data being in a weird state that script couldn't handle. So that's why I would say integration through data storage. It sounds great on paper. It's a nice, ugly, dirty way to do something real quick. When you're trying to get a MVP of an app up. but it is a place where the smell, like where you see this smoke, there's almost always going to be a fire.
Yeah, that makes sense. Now, the next code smell that we have is service failure creeps. It's a really creepy one over here.
Yeah, that's not the weird guy that works on services, by the
way. Yeah. When one service is running, a failure in another service shouldn't completely take it down. We've kind of talked about this a little bit, but this is more in depth. It may mean that some functionality isn't available or maybe delayed, but it definitely should not cause the app to crash or have a hard crash.
Yeah, and if you see a service completely fall over because another service is down or is having some kind of problem, that probably means they're too tightly coupled. Now, whether you can fix that or not is a whole other thing, but it's definitely a sign of a potential problem.
Yeah. Yeah, for sure. Now, this is an even stronger smell if the first service fails, takes down the second service, and then yet another service starts falling over. You know, if you've got your services stacked like a house of cards.
Jenga,
yeah. Or if multiple services fail due to a single service failure, that's where you've got like too much like at a core thing, you know. Even if you can't completely stop services from having problems spread through the system is extremely destructive for stability.
Yeah, if one service can cause another service to fail, that means that the system uptime is always going to be inversely proportional to some multiple of the number of dependencies that you have.
Yeah.
Right. And that's actually in truth what happens anyway. The number of dependencies you have is the number of risks you have. But you kind of want to keep that relationship as tight as you can. Where it like, okay, this makes it where I get 5 nines of uptime instead of 6 because I added these 2 services. I'm okay with that versus this makes me get 1 9 of uptime.
Yeah.
By the way, that's percent, or that's not percentage, but like decimal points. So 1 9 of uptime is 90%.
Mm-hmm.
That's not a real good place to be.
Right.
Excessive coupling between services. This is kind of the stuff we're all talking about anyway, but sometimes it's not just the communication mechanisms that make it jump out. Sometimes it's the communication mechanisms between the developers that make it jump out. So when the authors of one service have to know the inner workings of another service in order to work on their own code, that's an indication that the services are overly coupled.
Yeah, that makes sense. Now, beside the typical problems such as cascading service failures, this excessive coupling also means that more errors are likely as communications between groups of developers working on different services are never really perfect. Yeah.
It's like British understatement.
Yeah. That's like, not even close. But yeah.
Yeah, that's right. At the same level of I find myself disagreeing with the Taliban. As far as understatement, yeah. This excessive coupling with the errors and the communication, it's something you have to see because we all have this mental model of, well, people just talk and it'll fix it. But the problem is that's also a communication channel and it's an imperfect one. And people leave, people come in, people get the wrong idea, people don't understand the words that the other dude's using. It's never going to be perfect. Like we know this from human personal communication anyway, but we completely ignore it in a business environment rather blissfully until it blows up. Really what this ends up being is a manifestation of Conway's law. Now, Conway's law, it would be in one direction or the other. But basically the idea here is that the communication structure of a company or of an organization determines the code structure. So you have 2 different teams, they're working on 2 different services. That's a great way to actually pull 2 parts of the system apart. You can actually kind of cause a little bit of mitosis on the team there and do that. But if you have to have that communication channel work and you have 2 separate teams, it's kind of hard to get that right.
Yeah.
So the less coupling you have, the better off you are because they do not communicate perfectly and you cannot assert that they will.
Yeah. And just a little side note here. I think it's a really good idea to rotate developers around, not too frequently, but so they get a feel for it. Like when I first started as a lead last year, I worked on one of our kind of more central services, and now I'm working on a more line of business application that uses that service. And so having that little switch up there, I know a lot about that service that we're using, which makes it really easy to communicate with the developers who are working on it and say, hey, we're having an issue with this. Or like, it's not just, hey, it's not working here. It's, hey, here's like the line of code that's causing the problem because I remember writing it.
Yeah, you do have to be careful though, and not encode that knowledge in the client.
That's true. That's true.
Because I've been bit by that the other way. That's what I'm telling you.
Yeah, I follow what you're saying. Yeah,
then you're responsible for both of them.
Yeah,
I just want to throw that out there because hurts.
Yeah. All right. So the next code smell that we have is long connection lifetime issues and zombie connections, which, considering yesterday was Halloween, I mean, it's going to be like a month later when this comes out. We should have recorded this a month ago.
Yeah, well, this is way spookier.
Yeah. If one service connects to another and keeps the connection open over a very long period of time, this is often an indication of looming problems with the integration. It can also be an indicator that services are very overly coupled.
Right. So they're opening a socket and, service A says, here's some stuff. Service B goes, I got your stuff. Here's my response to your stuff. And service A is back, oh, here's some more stuff. Right. And they keep that connection open, not a stateless connection, but an actual open socket. I typically look at that and I go, these two they're too closely connected, and more than likely the developers don't understand the networking under the hood that's going on there. This one really sucks the first time you run into it, because you'll look at both endpoints and you'll be like, they both say they're working. Am I taking crazy pills? And it's like, no, you're not taking crazy pills. Your network admin is taking crazy pills.
Yeah.
You can keep TCP connections open over a long period of time, infinite time, between two devices, theoretically. But that doesn't mean that the connections will be maintained by the devices in between the services. There's no means of making those endpoints aware until they try and they fail. Now, what a catastrophic failure looks like here is a retry logic type thing. So it's not as simple as, oh, I tried and it just blew up. It can be, but it doesn't always work like that.
As an additional complication. But wait, there's more.
Yeah, there's always more. There's always one more.
When these connections fail due to a device in between them, they take forever to do so, and do it in very unpredictable ways. Like, it's not going to be obvious.
Yeah, one of my favorites is when it tries to reconnect and the other device, it can't reach it because, hey, somebody put it on a different VLAN, or they moved some hardware around somewhere, and all of a sudden that connection's not there anymore. It may retry and not be able to connect, but it doesn't like hard fail necessarily. It times out, and depending on what your timeout is and the number of iterations, this could be, you could be sitting there for 20 minutes before the thing goes, yeah, I can't do it. You do not want that in your enterprise data center for some app that faces anyone.
Yeah.
Ideally, you really want inter-service connections to either be entirely stateless or short-lived, if they have to be stateful. So if you do have to open a socket and do something, you do it, and then you disconnect. Right. This is why we do our database connections the way we do, right? You open the connection, you do your thing, transaction commit, and then the connection goes back in the pool. It's for that reason, so you don't get these zombie connections.
So the next code smell is excessive point-to-point communications. You should also pay really close attention to how services talk to one another. If services are directly connecting to each other, rather than going through a queue or some other layer of indirection, you should understand that this is not going to scale.
Right. And, the best example of this is when you have multiple instances of a service. You've got them load balanced, something like that. Well, the load balancer is in between. right? So that takes care of that problem. But what if you had a service, and I've seen this in production in places, and I about pulled my hair out when I saw it, where they're like, well, we have 3 instances, right? We have this other service that's writing to them, that's sending data to them, and it's going to know about those 3, and it's going to call them individually, and they're going to call it individually because it started as one-to-one, and they're like, oh, we need to scale out. And instead of actually fixing the problem, they just go, well, this is easier because I can do a for loop.
Yeah.
Don't do that. And you won't see this one as much now because you'll see it in older code. You won't see it in newer stuff because now we've got a lot of infrastructure stuff that's easy to spin up. And you can just say, hey, put it in AWS. I want to put a load balancer in front of this thing. Here's how many instances I want. They're Docker containers. It's not, hey, I have to go physically buy another device for the load balancing and configure it. And, some dude with a, trucker length beard is going to have to, know exactly how it's going to be configured and the IP ranges and everything else. Back in the day, that was the thing. And so people tried to hack around that. And some of those people are still around and don't know better. And they tend to be senior.
Because they've been around long enough to
fossilize. Yes.
Mm-hmm. Yeah. So if you do anticipate scaling, this pattern indicates some areas where you will likely need to alter business and integration logic before you're able to actually scale.
Right. Because people that do these kind of things, they're like, oh, I'm opening a connection, I'm sending some data, I'm getting some data back. And they don't account for the other service potentially being slow. Right. So instead of going, hey, I'm doing a call, I'm submitting a job, and here's your webhook to call me back on when you're ready. They keep a connection open. And so that's an architectural smell that is probably not going to work well for you. You don't see this a lot, but it's come up enough in my career, and I feel like it's worth warning people about, just from that perspective. Now, something I do see still fairly often in the last 10 years is duplication of functionality between services.
Yeah.
So if you got 2 distinct services as opposed to instances or versions of the same service that have very similar functionality, this is an integration smell that you really need to investigate because there's a reason for it. And it may not necessarily mean that, hey, things are broken, but what is likely to happen is you start pulling on this thread and it takes you to the places where the other things are broken because you have those conversations.
Yeah. So this typically indicates either a problem due to Conway's Law. I mean, honestly, at this point, we probably could have titled this episode Conway's Law as much as we've brought it up. A previous merger or acquisition, or some kind of underlying business logic that you just don't know about. And I mean, how many of us have come across that?
Yeah, I can think of a thing pretty early in my career where we had 2 services that were very, very similar. They pulled data from an FTP server. It was, comma separated data that was encrypted, and pulled it in. The schema of the data coming in was very similar. And it's like, why are the 2 services? Well, one of them was for Canada and one of them was for the US. There was a regulatory difference. And so they separated it so that if the 2 countries decided, hey, we're going to have different regulations, they're not under both of them on the same service.
Yeah.
Because that may be a conflict that says you can't do it, period. And so they went ahead and broke it. And that's why.
Yeah. Yeah, I follow.
And so you may just see something like that, but then you go, okay, well, now I know this, but here's some other stuff that's interacting with both that isn't split. And that's a potential problem I need to find too. So when you see this, it tells you something, but it's like somebody shouting in an indistinct manner. There's words, you don't know what they are yet. That makes sense.
It does.
Yeah. There's usually, if there is similar functionality duplicated between services, there's usually, not always, sometimes it's real dumb stuff. There's usually some kind of use case for one that's not available in the other. And this may also create errors for you in the future. And the reason for this is somebody that has used both services gets them confused in some subtle way and breaks something else.
Can't say that I haven't done that.
Yeah. It's just something to be aware of. I've also worked at one company that had 2 IT departments because it was a family-owned business, and the brother and sister didn't like each other, and they had their own IT department. They were in the same building with the same wiring, 2 different server closets. Yeah. I hope they're not still like that. I hope, somebody got bought out and they fixed it, but who knows?
I mean, did the IT departments at least like go, hey, this is ridiculous. We need to work well together if we have to exist?
Fraternization was not overly encouraged, but it happened quietly. Like everything was sneak stuff around. And when you got to do that, that's like Conway's Law squared. You just get weird stuff happen. Second order effects from that are very entertaining if you are there in a consultancy capacity and paid by the hour.
Fair enough.
If you're an employee, not so hot. And I was there as a consultant, so
you sat back and enjoyed the fireworks.
Yeah, I tried to keep them down because it was too much.
Yeah,
but yeah, I mean they hired me to fix some problems, and I was glad to get out of there when I got out. So
that's fair, man. That's fair. So the next smell we have is hub and spoke anti-pattern. This is another pattern that you'll commonly see. And it's typically when microservices get sliced off of a monolith, kind of somewhat acceptable if it is understood to be in a transition state to something better. Unfortunately, things can get left this way permanently. And I've seen...
That's the best time to have a layoff.
Yeah. I've seen this happen where it's like, hey, we're in the process of breaking off this monolith. What's really interesting is when you're like in the middle of doing that and the company gets acquired.
Yeah. And so now your halfway separated monolith gets to get reintegrated into somebody else's monolith.
Yes.
Yeah.
That's a pain.
Yeah. And it's way more painful for the people who bought it, who are probably going to be laying you off, and so you can giggle. Because there's what is the as the great philosopher Benny Hill once said, he who laughs when things go wrong has just found someone to blame it on. Yeah. And there's going to be 1 or 2 older people that get that joke. Now, essentially what happens here is that multiple services feed into and or depend on another service. And if that service goes down, the other services are also unavailable or severely degraded. So there's essentially a single point of failure. And like I said, this typically happens because you got a monolith and you're breaking pieces off. And they still got to communicate, and they can't, they're not ready to be in a cloud of interacting particles. They're still kind of around that central mass. But that tells you where your problems are going to come from because, hey, you're creating those problems right now. Or somebody started creating those problems and then got downsized.
Yeah.
So it's a place to look, is basically what I'm saying there.
Now, again, this is not necessarily something bad on its own, but more of an indication that you should look deeply into these interactions. In particular, you want to move the functionality that the spoke services are using out of the hub service and into their own separate services.
Right. Basically, in other words, get rid of that single point of failure and do it in a way that you haven't just created multiple single points of failure. And that's probably what somebody is doing at that point, hopefully. But that's definitely a place I look. Now, the next thing I look for is nano services as opposed to microservices. This is where you have an overly granular set of services. So instead of having, a service for orders, that handles all the order logic, you'll have one for creating an order, another one for collecting a payment, and, another one for fulfill order, another one for ship order. If your organization is actually big enough, like if you're Amazon, this is not you, right? Like that's a whole other, that's fine there. But if you're, some small, mom and pop, this is not a good deal. And, essentially what this does is you're saying, hey, instead of function calls, like I like this function call so much, I'm going to put a network interaction in the middle of it. That's not a recipe for happiness.
No, I feel that. I've actually broken down a few bigger services recently into smaller ones that it was more of a, hey, when we started this, it made sense to have it all together. But at this point, we're going to break it up just to make it easier to manage. And you have to make those decisions of, all right, how granular do you want to get with this? and it can be
Yeah.
easy to go that like to go overboard on it is what I'm saying.
Yeah, but I mean, like if you're Amazon, like your fulfillment service is probably a proxy for a whole bunch of other fulfillment services.
Yeah, that's true.
And large companies, that's a whole different deal. So we're talking, super granular.
Yeah, it really comes down to what you're doing. This is a situation that you do commonly see from teams who don't understand how to break a monolith into microservices. It's often a learning stage for the team. Probably always a problem if you see it, but it may not be the actual problem that you need to deal with right now. You're likely to have other issues, possibly with staffing or management, that got you to this point.
Right. So a great example of that is, I've worked in dev shops that it's like being on Darth Vader's Star Destroyer. You're getting promoted fast, but that's because the guy above you got choked. And you'll end up with a senior developer who's got like 3 years experience just at that company and has, read all the books and stuff, but has never practically applied stuff. And that's who's making those decisions because nobody else is around to say, hey, whoa, kill the motor, dude. So that's definitely something to look at. Now, I will add a caveat to this. Don't confuse serverless endpoints with actual services, right? You got a bunch of AWS Lambdas or the with Azure functions. I can't remember what they're called.
They're functions. They're just Azure functions.
Even though it's actually like more sensible than the way AWS named theirs, but we'll let that go. The thing with those is you may go, oh, well, they're separate services, right? Because they have a different lifetime, they have different deployment schedules, they've got their own infrastructure, but a lot of times they are still reading and writing from the same data sources. These are like controllers on what is really a service that happens to be implemented as a loose collection of Lambda functions or whatever. That is not the same as nano services. That's an implementation detail, not a thought process detail. So make sure you don't get those kind of confused, because that's not what I'm trying to say here.
That's a good point to make, though, because I could see how someone not super familiar with it could make that confusion, especially if they're learning. Like I had that misunderstanding when I first started learning about those types of services. So, I totally get how that can easily be made. So guys, the final code smell that we have for you is service splits based on layers instead of functionality. This is us kind of mentioning breaking up a larger service earlier. It's sort of what one of the things I ran into was like, hey, where do we break this off? But people who are very new to microservices often try to split services up based on the 3-layer architecture versus areas of functionality. And this is generally not the best plan because the main drivers for scaling tend to be areas of functionality, not areas of application structure.
Right. So like a great example of this is going, okay, most people are going to split their front end off, by the way. And they're not actually doing that based on the layering. They're doing that based on the code. The best way to code those is very, very different. And they have different characteristics for how they accept load and how you can mitigate load, because you can, you can put your Angular app on, an edge node somewhere and scale that sucker. And it's just static content versus, your backend code. And so it makes sense to split that off from that perspective. This is not the application layering thing. A great way to think about it is, okay, I'm going to split my business logic off from my data storage. And those are not going to be, two different DLLs or whatever, in the same, running process. I'm going to put a network connection between them. That's crazy cakes. Don't do that. It just doesn't make sense, right? Because if that business layer needs to scale for reasons, more than likely the data layer needs to scale for reasons. But if you put all your stuff in one and put all your stuff in the other, like scaling different functionalities separately is now not possible. And you've introduced failure points on the way. So yeah, I would say that pretty much, I've seen this done a few times and it's almost always an anti-pattern, but it's like using the database as a connection mechanism. It doesn't always get you. Especially, if you have very, very diligent developers who really, really know the guts of what they're doing, they can get away with this for a very, very long time. But it does mean that there typically is a lot more overhead without the corresponding advantages of splitting it a different way. And it also interferes with the ability to scale up or alter a piece of functionality without touching multiple services. Like you can't fix anything without going through all of them.
Yep. I've seen that before. Now, this also tends to slow down the development and release process because of the amount of extra coordination that is required in making sure all of your versions are the same. And if you do change one thing in one place, that it doesn't mess up everybody else who is touching it. That can be a pain.
Yeah, and it's even more fun when you've got different versions or different dialects of one of those services. So you've got your data service, but you've got a SQL dialect and you've got an Oracle dialect of it. And it's configurable at the business layer, which one you're talking to.
Oh, that sounds painful.
And you got interface contracts between those. And it takes so long to change an interface contract that if you want to send a different message from the back end to the front end or back into the business layer, that you're almost better off tacking it onto an exception and throwing the exception, because at least that'll go through.
You told me about that before.
Yeah. I worked on one like that, and that
sounds like a pain.
Yeah. I mean, I think the guy that did it is a pretty good developer, but it was early. It was really early in my career, and it was early in his.
Yeah.
Less early in his. But, yeah. And the tech then was like web service stuff and like old school Microsoft message queues and, and or opening sockets in many cases. So like I get, he had other crap to deal with other than thinking about the long term because he's like down in the weeds. But if you see this pattern, it means something.
Yeah, I would say that's how a lot of these come about is, a lot of times it's not that it's a bad developer. It's that they've got other things, or like we said with the Conway's Law, but it's usually, hey, there's something more pressing that they're having to deal with.
Yeah. And I mean, he was dealing with like memory leaks and, anything with old school, XML RPC or, old school web service, WS dash crap.
Yeah.
Whatever those were. And there's lots of them, but that's my, catch-all term. You're going to be fighting that stuff so much that you can't look up and deal with the other problems. So guys, there are dozens of possible integration smells that you are going to discover throughout your career. You'll probably add some to this list, and there's going to be some that you don't see anymore, I hope. However, there is always going to be some kind of small subset that you will see fairly consistently and that you're likely to notice early in a new environment, right? So you hadn't been there to be the one to write them. While not necessarily a problem in themselves, these smells are simply things that should inspire you to investigate more thoroughly, because they do have some meaning, even if it's not the one you think it is. It's also really important to be able to recognize clear anti-patterns, but it's even more important to be able to have a heuristic for things that might indicate that a particular anti-pattern is living there, because that latter one can make it easier to quickly point out quirks in a system's architecture that are worth exploring. That's pretty much all we've got. If you have a question or comment, please email us at neckbeards@CompleteDeveloperPodcast.com. Our theme music is an excerpt from Stand By for Titanfall by Pure Bells, available on SoundCloud and licensed through Creative Commons.
For references, show notes, and extra tips and insights, be sure to check out the website at CompleteDeveloperPodcast.com. Help us make the show possible by supporting us on Patreon at patreon.com/CompleteDeveloperPodcast. You'll get extras, including a weekly aftercast where we discuss the topic of the week and bonus material with some of our patrons.
You can also follow us on Twitter at CompleteDevPod, like our page on Facebook, and follow us on Instagram to keep up with news about the show. Join the conversation anytime via Slack by signing up at slack.CompleteDeveloperNetwork.com. Thanks for listening. See you next time.